Hello physics students. In this video, you're going to learn about something called Kirchhoff's rules. Now a couple points. There are two of them. There's a rule called the loop rule, and then there's a rule called the junction rule. And the other point I want to make is that you already know these rules. You learned them in the last video on series and parallel circuits. You learned about a bunch of rules about series and parallel circuits. Two of those were the loop rule and the junction rule. It's just that I didn't call them that in the last video because there's already enough information for one video. So today we're just going to formalize those rules and call them by their names. So Kirchhoff's loop rule, a little bit of a funny spelling, that's really how it's spelled. So here we are, the first one called the loop rule. Here it is. The sum of the voltages around a circuit loop is zero, or stated as a formula like this. This is a sum sign. Oh, I forgot the word loop. So around a loop, well, hopefully you could read that, but if you can't, we'll just put in the word loop there, is zero. So what do we mean by that? So here's a simple series circuit. And like I tell students every year, in order to apply the loop rule, what you should do, the best way I believe, is to imagine you're a tiny little ant with a tiny little voltmeter walking around a circle in a loop and measuring all the voltages, tallying them up, and then when you're all done, adding them up and seeing that they equal to zero. So imagine the ant, our little ant, begins right here at this starting point and walks in the direction that the current is flowing. So the ant's going to walk this way with a tiny voltmeter. So the ant encounters the battery first. The ant then has to step from the negative terminal of the battery to the positive terminal of the battery. So the ant is like going up in volts. And it takes its little tiny voltmeter and puts one wire at the beginning and the end of the battery and measures the voltage of the battery. So it enters into the equation and it goes to higher volts plus V of the battery. Now the ant continues his little journey around and encounters a resistor. It's going to walk through that resistor, and resistors do have voltage across them from Ohm's law. If you solve I equals V over R and multiply the R to the other side, you get V equals IR. So a resistor has voltage across it if there's a current flowing through it. But the ant is going from this side of the resistor and walking to this side, so the current flowing this way always flows from high to low volts. So as the ant is stepping, it's stepping from high to low. It's going down a certain amount of volts through the resistor. How many volts? Well, it measures it with the voltmeter and it enters it into this equation and adds negative V1 because it's going down the volts of resistor 1. The ant continues the journey, goes down the voltage of resistor 2, and then down the voltage of resistor 3, and it's completed its loop. It's gone back to the starting point. So according to Kirchhoff's rule, whatever these voltages are, 2 volts, 5 volts, 7 volts, when they're plugged into this equation, it should get 0 for an answer, that ant. So now we have this equation from Kirchhoff's rule, but if you look, we can move all these negative voltages to the other side, and it gives us this equation for a series circuit. And as I said, we learned that in the last video. By the way, I didn't show you in the last video, but these formulas for series and parallel circuits are in the reference table. You don't have to memorize them. So where are they? Well, they're in the electricity section. And here are, let's wait for the focus, the equations for the series circuit for resistance, voltage and current. And as you can see, the voltage expression V equals V1 plus V2 plus V3 is what I just derived from Kirchhoff's loop rule. So this second equation for voltage in a series circuit is just an expression of Kirchhoff's loop rule solved for the voltage of the battery. Okay? The parallel expressions, by the way, are here. So you have that current, voltage, and the resistor rule is written. I wrote it a little differently on the board in the last video. I solved for REQ by flipping both sides over and getting REQ is all these added together to the -1 power. I like to write it that way because that's what we're going to do anyway. And as I mentioned, by the way, a little aside, this is not the same as REQ equals R1 plus R2 plus R3. You cannot flip both things over, both sides over, and just call this just R1 plus R2 plus R3. Give you an example. Let's take 3 ohm resistors. 1 over 3 plus 1 over 3 plus 1 over 3 is 1. Flip that over and you get REQ equals 1. But if you did REQ as just R1 plus R2 plus R3, you'd get REQ equals 3 plus 3 plus 3, 9 instead of 1. So yes, you really have to add up the reciprocals, get an answer, and then flip it over when you're done. But anyway, I got a little sidetracked, but the point is that these rules for series and parallel are both all of them are on the reference table here. All right, so Kirchhoff's loop rule turns into this for series circuit. Let's move on to the other rule, the junction rule. And the junction rule says, oops, I must have bumped into the board here. The sum of the currents going into a junction equals the sum of the currents going out of a junction. What we mean by a junction is a place where wires connect, okay? So that you could either solder the wires or twist them together, but the wires all connect at this point. We call it a junction. Stated as a formula, we could say these words equivalent to I in equals I out. All right, let me create a pause to allow you to copy these notes down. So let's move on and see, as I said, we know this rule already. We knew this rule, we know this one already from the series and parallels topic. So here's a parallel circuit, okay? And I drew it a little bit differently so it's more conducive to demonstrating this principle. We got current coming out of the battery, and then here's a junction where all 3 of these resistors meet the wire coming out of the battery. So there's our junction right there. And from that junction, we're going to have current going through resistor 1, 2, and 3. The junction rule says that the current going into that junction, in other words, what came out of the battery, equals what goes out of the junction. In other words, the current going to these 3 resistors. So, I1 plus I2 plus I3 is the current going out. So there is the expression of I in equals I out. And if you go to the reference table, I won't go to the camera again, but you would see that very same formula for a parallel circuit. All right, now what I'm going to do is just a quick example because these examples are just really kind of quick and easy. So here's looks kind of like a little bit more complicated, but what we could do is we could think of this entire section of the wires as a junction, okay? So all of this, and what we have are 4 wires going into this kind of array of junction wires. And so we could use a junction rule for this segment of the circuit here by having I in, the 10 amps, and then what's out is in the 4 amps. Those are going in. And the only thing that's going out of this arrangement is the 2 amps. So obviously what's happening is we got to have more current coming out over here. So it's going to go in on the I out side of the equation. And when you solve, you get 12 amps. Really easy kind of numbers and such. Now, if you wanted to treat this as 2 junctions, you could say I in equals I out over here. And what that would mean is that coming out of this circuit is 2 amps. Because now we have 2 and 2 equals the 4 going in. That means over here that 2 amps is going into this junction. So right now we have 10 and 2 going in. What's going out is obviously the 12. So you could do it as 2 junctions or 1. Gives you the same answer. So there's an example. Let me create a pause to allow you to copy this down. One more quick example with the loop rule. Suppose we had voltages given like this, like the battery was, let's say, 20 volts. Let's get a different marker. And then the resistors on the other side, this was 2 volts. This one we didn't know. And this one, I don't know, maybe it was 15 volts. What's the missing resistor? So 20 here, 2, 15. What's this one? Well, these have to add up to the battery's voltage according to the loop rule. So we've got 17 volts. What's missing is 3 volts. You could have written it as an equation using this, plug in and solve for the 3. Real easy again. The point is you just use the rule to solve for the unknown voltage. So that's it for today. 2 rules, the loop rule, the junction rule. We already knew them as the voltages add up or split up in a series circuit. That's the consequence of the loop rule, one consequence. And that the current total of the battery is the sum of the current in the resistors. That's one consequence of the junction rule. So I hope you understood everything well and you enjoyed the knowledge and that you enjoyed the video. I'll see you in the next physics video.